In this circuit, we're given both some known voltages, this 1 volt difference, this 7 volt difference, and this 3 volt difference, and some unknown voltages, V1, V2, and V3. We want to determine values for V1, V2, and V3. We aren't given any currents or any information about voltage-current relationships, so we have to rely strictly on KVL. Let's start out with a loop here, and I'll call that loop 1. If I follow the loop starting here and go clockwise and choose a sign convention such that the term is positive when I enter the positive terminal, I get V1 plus 1 volt. My loop enters the positive terminal at this element, minus V2, since I enter a negative terminal in the V2 element, and minus 3 volts. That brings me back to my starting point, so those sum to 0. At this point, I have 2 unknowns and only 1 equation. I either need an additional equation or a different equation. Let's see what I get when I loop around here. I'll call this loop 2. I'll start down here, and I'll assume that if I see a positive terminal first, I'll add that term. If I see a negative terminal first, I'll subtract that term. So I see the positive terminal on V2, so that's a positive term, and a positive terminal on the 7 volt difference, so that's plus 7 volts. This one I can solve for V2, so V2 is equal to negative 7 volts. That takes care of 2 of my problems. I now have a number for V2, and I can now use this and my previous equation to solve for V1. So V1 plus 1 volt minus V2, which I substitute negative 7 volts in for that, minus 3 volts is equal to 0. So V1 is equal to negative 5 volts. Now let's try an alternate approach to find V1. Remember that I can loop through any set of elements as long as I end up back at my starting point. Let's try a loop that goes all the way around through these elements. I'll call that loop 3. Now this loop has this as an unknown, but all of the other voltages in that loop are known. So in loop 3, again, if I enter a positive terminal, I'll add that term. If I enter a negative terminal, I'll subtract it. So I enter a positive terminal on V1, so that's V1, positive terminal on 1 volt, positive terminal on 7 volts, and a negative terminal on this 3 volt term down here. That brings me back to my starting point, so that sets equal to 0. And from this, I can also get V1 is equal to negative 5 volts. I get the same answer both ways. However, depending on what I want to find out, one of these equations might be easier to work with than the other. Finally, if I want to find V3, I can loop in here. Let's call this loop 4. I have one unknown voltage, V3, and one known voltage. This one's a piece of cake to solve. I'll stick with my usual sign convention. If I see a positive terminal first, I'll add it. If I see a negative terminal first, I'll subtract it. If I start down here and loop this direction, I see this positive terminal first, so I add that term, plus 3 volts. As I come around here, the next voltage I see is the negative terminal on V3, so I subtract V3. That sums to 0 since I'm back to my starting point. And V3 is equal to 3 volts. And I've got values for the 3 voltages that I want.